Okay, good morning. Maybe because I asked for a homework yesterday, there seems to be the crowd is low, which is okay. Did you yesterday we were talking about structures that have corroded or have had some form of fault reported, and I asked to look for the youngest structure that had the issue. Did you find the youngest structure? No. Okay, so Google doesn't give you the youngest structure that has failed. Okay. Okay. What did you guys find? Did you find any issues with? Can you tell me the deterioration mechanism by which the structures failed? The ones you looked at. Did they fail by chlorides? Did they fail by carbonation?
Use of sea sand.
Use of sea sand. Okay.
Use of sea sand in Ecuador. Structure.
Okay.
Ecuador.
Okay.
And because of which.
That's very close to here, Ecuador.
That was a recent article which was published. So
Okay. Fair enough. Anything else? Anything else? Anything else?
Goa, there is a very bad precedence of the bridges.
Okay.
So it was very late, 30 years back.
Okay.
The Mondavi bridge, it was also due to the corrosion.
Okay.
And a lot of time it took for the investigation, and they could not, because it was all of a sudden, collapse was all of a sudden.
Okay.
So later, when they have extracted the material from the river, then they have poured in and then they have sealed. It was that the thickness of this one was very little.
The cover thickness.
So it
Okay.
has percolated into that one and entered the TB,
Okay.
and it has gone into the cables.
Okay. Was it a pre-stressed cable? Was it?
Please listen.
Okay. Okay. So it's the cover. The cover concrete was low, and the cover thickness was low. Okay. Chlorides, right? Was it chlorides?
Yes. Exactly, they could not figure out exactly. The probablers, they have said that maybe they might have used the water,
Okay.
or maybe the structural on the top of that one, it was only 50 mm thick,
Okay.
where the cables were embedded.
Okay. Well, 50 mm is a good thickness, but the question is how good the concrete was. Yeah, I mean, I'm assuming it's Goa, so I'm assuming it's marine region, so you have salt in it. So
And I found a book which has a lot of case studies.
Okay.
One of them,
okay,
I will be keeping with my.
sure. Okay, is it an internal book to L&T or is it just the? Okay, good. So anybody else? Any other case?
Segmental built in USA, the bars that uses as decoated bars, but still due to chloride penetration and all, it gets corrosion and bacteria. Severely within 10 years of the construction.
Okay, what bars did they use? Sorry.
Decoated bars, fusion coated, epoxy coated bars.
Oh, epoxy coated bars. Okay. Did the structure corrode or did it fall?
It's like due to this handling and computing under the, and it gets corroded heavily.
Okay, but it didn't collapse. Okay, good.
Needs maintenance and repair. Still.
Okay. Okay.
Florida, USA.
Anyone else?
I encountered a case in Gujarat for caustic soda plant.
Okay.
So the condition of the structure was so bad that it fell off, obviously.
Okay.
It was also done, jacketing was also done there, but still the penetration is so much higher that it has completely eaten away the whole concrete section. So it was not able to take up a load of a simple tank.
Okay. Okay.
The structure definitely failed.
Was it a load carrying structure in the sense of vehicle structure or is it just a factory structure? Plant structure. Okay. Caustic soda. Anything else? Why would caustic soda, sorry, I'll come back to you in a second. Why would caustic soda affect the structure? How?
This is a plant. It's a manufacturing plant.
Yeah, but I'm assuming
Produces the caustic soda.
that's the exposure environment or carbonation, give or take. But from what you're describing, it seems very much an internal failure, which is
And that plant is also nearby.
that helps. Okay.
In Kuwait in 1932 also, one telecommunicating training build thing was created, and within 10 years of its construction due to sulfate attack,
Okay.
its concentration is like 2 to 5%. Still it got 1% that foundation below the foundation, like 4 meters below the ground level, and there is settlement of like 1 degree.
Okay. Okay.
The failure like gets treated over.
So it's a settlement. Well, there's settlement. And this is the problem with the structures that report a fault, because you've a lot of information coming in. So there's foundation realignment settlement. It could be due to soil. I presume it's a sandy soil, or it could be due to the structure itself collapsing.
Foundation itself, the sulfate attack was done.
Okay.
Corroded during ceramic.
Okay. Sulfate attack. We will come to the mechanism of sulfate attack in concrete, okay? Generally speaking, we expect sulfate attack to be an expansive reaction, not shrinking. So if you look at the foundation, if the sulfate attack is more prominent on one side, we expect it to expand, which might result in your tilting. So which means the tilted region may not have the sulfate. Never know. You can only presume. Okay.
One more post-tension grade in Germany, the grafting was not done properly. Actually, the grade of the mortar that they have used for grafting is not like proper.
Okay.
Due to which, due to gravity conditions and all, the nearby seashore also got
So,
corroded. The
Where,
cables also corroded.
where is that? Do you know where the structure was?
Germany.
Germany. Okay. Germany has very little seashore, so it must be in the north of Germany. Okay, so it seems chlorides play a large part in all of these failures. But you know the best and the more alarming thing? That is from India. It's reported from India. That's from India. And that came only because you knew the structure. Okay. That also, I don't know whether it was reported, the Goa collapse, was it reported? I'm sure it was reported then. If it's a collapse, it'll be reported. Does that mean in any way to say India doesn't have any other structures that are affected? Or is it the lack of reporting? For such a vast country, I expect majority of the structures that are 50 to 60 years old should have some form of issue. So it's probably the underreporting of it. And the reporting only comes in if somebody has a keen interest in reporting it. Unless it collapses, nobody else really bothered to report it. I mean, the news media won't be interested. If you tell them your structure is leaning or have some expansion, it's not sensational enough. So that doesn't mean by any way to say that the structures are not affected by things that you see. But remember the pie chart we had seen yesterday where in the UK 33% of it is structural collapse or structural structures affected are due to chlorides. Okay. That's us being a moderate climate. You're far from a moderate climate. You have a higher temperature, you have a higher humidity, and you have a very vast sea and marine exposure, which means you're not a moderate climate. So majority of the structures on the coastal belt, I would expect it to be affected by sea salt. Okay. As the country is developing further and further, you should also expect the carbonation to be more prominent, especially in the urban areas. In between areas, you can expect a combination of both. Okay. That is not a geographic representation. It could also mean a structure close to marine location can also have a carbonation exposure along with it. Or even within a structure, you can have both. Okay. So that's that. But majority of our main cities are located close to the sea. which means the exposure is rightly there. Okay. What are the forms in which salt can travel? Can salt travel to distance? How? So it's windborne, let's say atmospheric. It's the splash, which is in direct contact probably, and then the submerged zone. So in the UK the classification is based on these three. But there's also the fog, which can go further and further. So if it's a flat terrain, a flat area, sea salt can travel much further because the fog will carry it all the way where it needs to be. So there are reported cases, I think in Namibia, where the corrosion was reported nearly 100 kilometers away from the sea. There's not much between the sea and the structure. There was a water tank. So just look at the examples coming out of South Africa. They're starting to look very closely at all of their structures. South Africa is also a seaside town. So most of these examples come from a region where people are studying that very closely, and that's why they're reporting it. Okay, this is what I'm expecting, that in the few years following, you guys will be starting to report more and more of these structures. What's the benefit of reporting? Publication. What's the benefit? The academic community will have their own benefit, but beyond that, what do you mean by publication?
Can you
Okay.
can design the buildings properly the next time?
Okay.
The mistakes.
Choose the materials properly.
Okay. So you're basically you're communicating your best practice to others. Isn't that right? That's what we're doing by publication, isn't it? So you found a problem and you're communicating that problem to others, saying these problems exist and this is an approach that we've adapted for the site. Every site requires a different approach, and here's an example that you can follow. Okay, so publications quite often receive criticism. Okay, so in news media you will see below that there will be a lot of comments. Okay. Most of the technical journals nowadays have such a feature added to the publication. It's called a response letter. So you can respond to the publication saying such and such approach might only work in certain case. It's not applicable and such. So when you read an article, also read the comments, because comments are very important. A publication can be accepted depending on the reviewer's personal opinion. But people who are commenting on it can help you to find the faults in the approach. So when you look at technical journals, iStructE or ICE, New Civil Engineer, Institute of Civil Engineers have a journal called New Civil Engineers. You should be able to access it online. For those who are students, you can just register for free and you can access it. They report case studies, and they're quite a comprehensive review of the civil engineer's view of the case study. And those are good collection for if you're looking to collect together case studies, or if you're looking to collect lecturing materials for students. If you go online, you can see below the case study there will be comments as well, and those comments are very critical, so have a look at that as well. And if you're developing case studies, if you do work on a particular case, report it, because obviously as a company you probably don't want to report the IP part of things, but even stripping the IP you can still report it, either in a conference proceedings or working in one of the technical journals. You can strip off the IP part of it, you can strip off and anonymize the structure if you wish. But such reporting will help you to get more work, obviously, as you are already aware of it. But it will also help you to identify any shortcomings of the work that you may not have seen, that the others have seen before by the comments. And that's why I suggested anonymize the work, because you probably don't want to be exposing, saying that I've done the work. This is an area where you may not know all the answers, nobody may know all the answers, but others might know some part of it that we don't. So we just need to open it up. And if you look at evolution of structural engineering and the fact that we have codes now, written codes, it's a path. It doesn't happen in one day, it happens over time. We make mistakes, there's a lot of mistakes we were made. Now we're coming to a stage of we're really confident our structures can last the loading. That's because of years of practice and years of failure and learning from failure. Most of the UK education is based on learning from failure. So everything that we do is we make it, we break it, and we teach them how it breaks. And then we ask them to put it back together to figure out why did it break, what can you do for them not to break. Okay? If you look at in a different way, so bending moment, let's say you're teaching bending moment. Would you take a beam and you break the beam and you show them what the principal bending moment were when it failed? Is that how it works? In the universities? Or you just draw it on the board saying this is the principal bending moment, this is how it works. So the laboratories that we organize, you need to look at it that the students can gain the knowledge from breaking it. Okay, so let them make a concrete, let them crush the concrete. I presume most of us will be tempted to say, this is the compressive strength. This is how you derive the compressive strength. Have you shown them how the structure failed and what it looks when it's completely failed? And in the code it'll also tell you n number of ways it should fail and n number of ways it shouldn't fail. Okay? Let them look at that material and see whether aggregates have been broken. What way did the cone finish? Do you know the way when you break a cube, you get two conical shapes in the end? Why is that? So you can answer that question yourself. You can go and explain to them in that fundamental level and show them the cube and help them learn that way. There's a reason for saying all of this, because students are only with you for a certain number of years, 4 years, 3 years. And if you can teach them how to learn rather than teach them everything that they should learn, they can learn further. Okay? Quite often, even in the UK, quite often the concept is to teach them everything. You really can't, because it's such a fast evolving field. So you can only give them a limited exposure of what we know, presumably 5 to 10 years prior to our knowledge, and we're teaching that to the students. Maybe better to teach them how to learn. And don't worry about the topics. So the Royal Academy of Engineering is very keen that we move away from mathematics. The heavy end mathematics, we move away from it for engineers. And they're not by any means saying they shouldn't learn the mathematics. For those who are interested in the mathematical part of it, let them have that as an elective. Okay? But don't force engineers to be precise up to 3 decimals of calculation all the time. Because when you look at people who are practicing, you're not doing 3 decimals of calculation. You're trying to figure out what's happening. You're on site, you're looking at the massive thing. Where am I going to start? That's a skill. And that skill you get by practicing. So what universities can do is to help them to learn from those aspects. So give them a challenge and say, learn and tell us how this is going to work. So the university system is evolving. US is ahead of us anyway. But there's new universities starting in the UK which is entirely problem based. There's no blackboard. There's no presentation. They just put out a problem and then tell them to come up with answers on how to recreate it or how to make it better. Okay. There's a new university coming up just over north of Wales, Hereford. Have a look at what they're planning to do. They're not set up yet. They're in the process of setting up the university. They're supported by companies like Dyson who are looking at brand new technology. They don't want to know the mathematics of it. They want to know, does it work? Can it be better than the existing solution? And if they need the mathematics, then they go and look at their own lecture materials, which is given to them in a tablet, and they can learn, they apply, standing in a laboratory space. Anyway, besides that, So I wanted to highlight those issues, and we're going to look at some of those issues today. Just to summarize from yesterday, and I won't go too far into the corrosion side of it, but let's look at corrosion here. Any of these issues, it might affect the concrete part of it, or it might affect the embedded steel in it. Okay. If it is concrete, we might get a bit of warning because we can see things happening. If it's steel and if it's very focused, there's no warning, especially for pre-stressed tendons. We have no idea what's happening inside the duct. So if the duct is fully filled, might have a better chance.